Hello guys, I'm Peter from Builder Boeing. This is the Rudder trim panel, a panel that I at least use very little, and to be honest, for the first 12 years it wasn't even interfaced. I just put a rotary switch here where the knob goes, and then I had some LEDs that lit up when I turned the switch, and that was it. That has changed now. Now it's interfaced, and the reason is I got my hands on this bad boy, which is, you might recognize it as an OEM switch. It is the real Rudder trim switch from the Boeing 737. I got it, as I recall, very cheap, around $15, something like that. And that's the reason that I bought it and started making this panel. If it had been $50, I've never started interfacing with OEM. But for $10–15, that was a bargain, and I started making the panel. The switch itself is, as it is OEM, of course, has a wonderful feel to it. When you turn it, it is very sturdy, so it has require a lot more force than those normal rotary switches that we use in light electronics. This return to spring-loaded to return switch, so when you release it, it automatically goes back to the upright position. Very cool. The wiring is a bit special on this. When you turn to the right, you get a signal on a pin for the right side signal. If you turn it to the left, you get a signal on a different pin for the left side signal. It goes in two positions. I'll just put it close to the microphone. You might be able to hear the clicks. Here we go, the first. There's one click. Let's do it again. That's the first click. And then you can go an extra step. There we have the second click. So you can see, first click, second click. You can just go extra, like you want to trim it even faster to the sides. If you turn it here, you get one signal on the right pin. If I turn it here, I get one signal on the right pin and one signal on the ×2 pin. If I turn it over here, left pin, of course, over here, left pin and the ×2 pin, but the ×2 pin is the same regardless if it go left or right. I hope that makes sense. I haven't tried interfacing it yet in ProSim. If ProSim supports that ×2 is one pin, it isn't an extra one for each side, it's one pin. So it needs to combine the right-left signal with the pin that's shared down here for the ×2. We'll see how that works. For the trim indicator here, I had different ideas. Should it make like a roll that could go around, or should it use poly belts, or how should it do it? Should it get a screen? And I ended up with, everyone that has 3D printers are very familiar with these poly belts. And I'll show you in Fusion 360 what I did. This box is my own design from Fusion 360, and the poly belt is held in the enclosure here using these wheels that's bought from, I don't know where, 3mm bore. And you can see the wheels here as the red part, and the entire poly belt goes down through the holes here at the bottom of the structure. On the back here you see some teeth, and that's because that's where the servo mount goes. I'll just show you here. There's the servo mount, and if we change colors, you can see the green part here. That's the servo mount. The servo is the light red part down there. The clever thing about these teeth is you can move the green part up and down, and once the poly belt has the right tension, you can fix it with screws and gives you, no matter what length your poly belt has, the right tension. The yellow wheel is made in Fusion 360. It has 110 teeth, which covers the length that the poly belt needs to go. There's a function in Fusion 360 where you just enter a few parameters and then the wheel is automatically made. So don't be frightened about this part making that wheel. That's dead easy. The star-shaped figure you see here in the back is for the mounting of the switch, including the hole. As the switch does take some force to move left and right, I did all I could to make sure that power will be distributed onto the rest of the structure so it doesn't break when you move the switch, but still allow for the backlight to go through. Here you can see the three pieces together. There's a wheel, there's a bracket for the servo, and then there's the entire box for the trim control and for the switch itself. It has a servo connected. I've used one of the larger servos, not the small 9 grams, but a larger one, heavy duty with metal gears, because it does take some force to move the belt. On the poly belt, I just used a marker, like, I don't know, we call them Posca in Europe. You can write on stones, you can get a white one. So the arrow you see there is actually just made with a pin, white pin. And I've had a servo test board installed. You can see when I turn, it goes up and down. And back here, you can see the wheel turning around. I just want to show you one last thing with this pulley belt. There's like an off position. So when it turns off, it goes to the off position like that. You see that? There's a yellow off thing. And I was experimenting with you to make, like design a flag that went down on top of the pulley belt like you have on the standby instruments. And then I found out that actually in the real world, it's just made on the belt itself like that. So I've just painted it yellow, and then with a handwritten off, that's all there's to it. Pretty easy. I just want to cover this knob for you as well, because I think I made pretty good result from this. I downloaded a model from Thingiverse. You can get this downloaded from Thingiverse, but I had to adjust the bore here because it needs to fit the OEM version of the switch. It's bigger than regular D shaft or whatever you have, Knurl's shafts. And I also wanted to do something with the rudder letter. So I wrote it in Fusion 360. I imported this model and modified it a bit so the rudder letters are higher than the size there. So after I've printed it, I'll show you why. After I printed it, I used some masking tape like this. Now first I painted it all gray. First painted everything gray, and then I put on, when it was dried, I put on some masking tape like this, more or less. So where I wanted the black stripe, I had masking tape. Then I painted this part gray again, and that's very important because if you have like a small gap underneath the tape, the gray paint will go in and seal it, so it's the same color as the rest of the switch. And then I painted it black. So the reason for that, the first time with the gray paint, when you put the tape on, is if I didn't do that and there was a gap, then the black paint would go crawling underneath the tape. You don't want that. So gray first, you seal it, and then black is printed in white PLA. And so when this dried, I could just take a sharp knife and cut off the top of the letters, and then I had beautiful white lettering, a bit of coating with some varnish, and then I have this beautiful switch that I really like for this panel. It's going to be put together in this very huge box, which is very huge because the OEM switch is very deep. So that's the way it is. I was, for a short minute, considering OEM for the toggle switches as well. You can find them for around $20 each, so $40 for a set. But as I'm almost never going to use them, I thought it was just a bit over the top. So regular switches for now. It's going to sit in a pedestal, not being used very much for the next 10 years perhaps, who knows. We'll see. I'm Peter from Build a Boeing, and you guys take care. Bye-bye.